Hi folks, so in this question here we're going to be focusing on Leaving Cert higher level question. It's from the 2011 paper, higher level as I said, question B2, so section B, question 2, and it's focused on the area of axonometric projection, but specifically in that area on dimetric, okay? You've obviously got the isometric, dimetric and trimetric. So just read it, we'll zoom in here and we'll read the question. So it says here, the 3D graphic on the right shows an exit from Dublin's Porsche Tunnel. Okay, you can see they kind of give you a pictorial view here or a little kind of real life view. It says the outline of the exit is also shown as a line diagram in the thought bubble here. Okay, so they're showing you in a line diagram of what the actual structure looks like. I assume this is what we're going to be drawing. And then it says figure B2 below shows an incomplete dimetric projection of the tunnel exit using the axonometric axes method. The elevation and end view are also shown in their required positions. So looking down here, you can see they've kind of given us an incomplete portion down here using the axonometric axes method. They've given us the end elevation over here, and they've given us the elevation of it over here. Okay, we obviously don't need the plan then to complete the 3D structure. Now it says there then part A, draw the axonometric axes X, Y, and Z and the isosceles triangle ABC. So X, Y, Z axis, then the isosceles triangle A, B to C here. Okay, that's part A. Part B, draw the elevation end view orientated as shown, so end view and elevation over here. Then part C, draw the completed axonometric projection. And part D we'll get onto at the very end. In pictorial we'll talk about getting the traces, okay, of a plane that's cutting it. Now, starting off X, Y, Z, okay, that's what we're going to do, and we're going to get the triangle ABC. Now, looking at the sheet here, you're going to obviously have to pick an appropriate position. I always call this point in here the origin, if we relate it to, I suppose, SolidWorks or anything like that you've used previously. It's where all the planes, the vertical, the horizontal, and the end vertical plane are going to meet. I actually made a slight error there, guys, sorry for that. This is actually our vertical plane. So in this case, this is our elevation, this is our end elevation, which will be on our end vertical plane. Okay, I just should have noticed the XY axis was here, so there's our vertical plane. Okay, and obviously we've got our horizontal plane down here. Now, I'm going to have to pick an appropriate position for this because of where I'm going to draw this and this, and then I'm going to have to draw the AB as well. So if you think of the y-axis, if I was to extend that down and split it, you can see A to B is 14 meters long. Our scale is 1:100, so that's saying it's 140. So from here, we're going to extend it down. That means from there then, from the middle of the Y, it's going to be 70 to the right, 70 to the left. And that'll help me locate that isosceles triangle. We also have an angle in here between the X and the Y axis of 115, and it's 115 also on the opposite side. That is why it is a dimetric question, okay? Because two angles are the same. So on my sheet, and just try and twist it in there neatly so you can see it properly there. So on my sheet, I'm after picking a point there. If you think of the borrows in the middle of the page there, and you can see obviously from the ground or the base of my page, really close to obviously where my finger is just coming into the screen, I'm after picking a point about here. If you think that's the middle, it's a little bit down from the middle. Okay, so first of all, I'm going to put in my y-axis. So I'll put my y-axis in first. I'll do it nice and light. So there's my y-axis. And what I want to do now is put in my x and my z. So using my protractor, lined it up on the origin and also on the y. I'm going to read around 115. So there's 100, there's 110, 115 would be here. I'm going to do the exact same thing on the opposite side. So setting that up, 90, 100, 110, 115 on the opposite side. Okay, so there's our x, y, z axis. Okay, so there's our x-axis, and there is our z. Now that we've that done, what we want to do now is put in the isosceles triangle A, B, and C. So, from my y, I'm actually going to extend it down ever so lightly, and from there, I'm going to measure 70 millimeters to the left. So you can see here, I'm using the t-square to set square on the line, and from there, I'm going to mark 70 to the left like that, and from there, just a little vertical line, or just to the, using that as a guide to mark it out to there. Now that I've got that in, I'm going to use a red now for my construction. From there, I'm getting in my edge AB, because this distance here to here is 70, therefore this distance also has to be 70. So I've now located A and B, which I'm going to write those in, A and B. And then simply to find C, what I'm going to do, doesn't matter which side I start on, from the z-axis, if I was to extend it out through, and extend it on, perpendicular to that line there, will be how I locate the C. So watch here, using my set square, just bring it up a little bit higher. So this line here, perpendicular to that, I'm going to rotate my set square, and from where it hits B, that will help locate me C, which is up here. So there's the C. Now that I've found C, it's very easy for me to connect it down to A. So that's part A of the question completed. Draw the axonometric axis X, Y, Z and the isosceles triangle ABC. Part A done. Now what we're going to do is draw in the elevation and end view, okay, as shown. So I have to draw in this view and this view. I'm going to start here with the elevation, okay, and I don't think I'll actually be able to complete it fully just yet, but I'll start with that one anyway. So where the z-axis is here, I'm just going to extend that a little bit further because I think I'm going to need it. So on the vertical plane, I'm going to project out everything parallel to the z-axis. So from A, I'm going to do the exact same thing. And then I'm also going to do the same thing from just a bit of sliding set squares here. Now if you have an adjustable set square, it makes life a little bit easier for you here. The sliding set squares works just fine, as long as you're safe with them. There we go. And now that I've this done, I'm just going to extend that one out a little bit further. Now that I've that done, I'm going to go perpendicular like that there. I'm going to go to about here. Now that's gone perpendicular. Now that I have the direction of it, I'm just going to extend it on. Okay. Now what I want to do with this line here, I want to get the middle so I can draw in my semicircle. So I need to bisect this line. So put your compass here, pick a distance that is greater than halfway. If that's halfway, you want to go slightly greater. Swing an arc and an arc, go to the opposite side of the line, swing an arc and an arc. Where the opposite side of the line is, I'm going to connect here to here. I've now found the middle. Now that I have the middle, what I'm going to do is semicircle. Yeah, happy with that. As you can see, there's my semicircle. And what helps me then is where the z-axis so extends on, and it was to hit here. I'm going to extend that up to there like this. And this one out to here. And there you have it. That there is a point view of my z-axis. This is my x, and this up here is my y. Okay, it's the exact same we're going to have to do on the opposite side of the sheet over here. Now, what's important to note though is they don't really give us many measurements. They give us one here, 3.5 meters. Okay, I'm just going to zoom in there. They give us one here, 3.5 meters up, which I'm going to put in along this line in a second. But they don't give us the height up to here, which we're going to have to get from this view over here when we get that completed. But what they do tell us is the length, because we have this point here. Okay, and we also have this point because that's on the semicircle that we're after drawing. We actually do have the length of the object. Okay, so I can start putting in that information there. So as you can see, I can actually heavy in from here to here. So that's the length of the object. And then they also give us, as I said, the height, which was 3.5. So 3.5 up to 0. That's that one there. Heavy that in as well. Now that I have that, get a sliding set squares here on that first edge. Heavy that over to there, and heavy this up to here. That's that first portion. Okay, obviously, as you can see, we're missing the curved portion here. Okay, so now that we've as much of that one done as we possibly can, we're going to move on over here to this one here on the left hand side, which in this case is the end elevation. So like we did previously over here, I'm going to extend out. I'm going to extend out, in this case, my x-axis. As far as I think is required. And then parallel to that, slide it up. I'm going to do the exact same for C. And then slide it to about here. Move my set square around to the opposite side. I can get further distance out. And always just scroll back here, just make sure I haven't. Yeah, still happy with that. Okay, now I'll rotate this perpendicular. This guy up to here. So once again, so I can just get a little bit further, move this up, like I did out here. Once again, that line there is now parallel to the edge AC. So what did I do over here that I have to do here now? I have to bisect this line so I can get the middle for my semicircle. So from here, that's about the middle there, pick a distance that's greater than halfway. Both sides of the line. Keep the same distance on your compass. Okay. And then get the middle, which is just there. Now that I have the middle, I'm going to pick the radius for my semicircle. What I would always do is I would just check on the opposite side that it's lining up. Yeah, I'm happy with that, and then draw it in. There you go. There is our semicircle drawn. Now where the x-axis extends on and hits here, that's going to be a point view of my x-axis. So once again, I've got my y. In this case down here is my z, and this is a point view of my x. Now what we have to do is we have to draw in our elevation, or our end elevation, I should say. Now, once again, we have the height here. We can see that height, but it just tells us radius for the curved portion. But what's helpful to us here is we can actually see we've got a semicircle here that is in line with this whole line here that we're after just drawing. Okay, from here, which is where the semicircle originally was, from this point here to here. So as long as I can bisect this line from here to here, I can get the middle, then I can do my semicircle, and that will help determine to me the overall height. Okay, and I've obviously got this 3.5. So I'll just zoom out there. So the line from here to here is where I'm going to get my little semicircle there. So once again, we actually have to bisect it. So pick a distance, as always, greater than halfway. There we go. Now that I've that bisected, from there to there, that's the middle. I'm now going to draw in that semicircle. As always, just check it. Yeah, happy with that. Nice and slow. Okay, I'm after drawing that in. But first of all, I'm also going to put in the height that was over here, 3.5. I'm going to put it in on this side. At 3.5, I've marked it there. That's helpful to me. I'll bring this across. And then from there, it's going to go perpendicular down. And likewise with this one. Maybe in this portion as well. And then the last little bit, I suppose I can heavy in as best I can. roof portion as well. Now that I've got the height of the roof portion, which is from here up to here, I can bring that height over here. Once again, just a little bit of sliding set squares in line with the XZ line here. That's that line. You can now heavy in that up to there and this up to here. Okay, there you have it. That there is our elevation here completed on our vertical plane, and our end elevation here completed on our end vertical plane. Now the next bit we have to do, that's part B of the question done. Draw the elevation and end view of the orientated as shown. Now part C, draw the complete axonometric drawing. What they're essentially asking us to do is complete this structure in here. Now the bit that we might struggle with slightly is simply just getting the curved portion here, and we've also got a curved portion up on the top as well. So those two curved portions are going to be the challenge. And as you can see, they've kind of given us a representation up here. Okay, and we're going to use ordinates to help us complete that. So that's what we're going to move on to now. But before we even get started, we're going to start with as much of the easy stuff as we possibly can. So you can see here, this line has already been projected down, so I'm going to extend this back down here, because I'm going to need that in a second. That's the length of the drawing, so that one there is just going to extend down. Likewise with this one here, so they're all going to come down parallel to the axis. So this is parallel to it, so I can use this as a guide. So from this point here, it's going to come down parallel. And from this point up here, parallel. And likewise, just slipped ever so slightly there, so just be careful of something like that happening. Just line it up again as you need to. So come down, about there, and likewise with this one. Okay, now I have to bring down some more of these here. There's that one. As you can see, I'm just lining up the sliding set squares. I think it's as far as this one yet. And then this will be the one here at the back. Okay, so that's as much as I'm going to get at the moment. So from here up to here, it's going to be a heavy line. Out to here is a heavy line. Up to here. This portion here as well. And then finding this one at this side, just make sure, yeah. Okay. And based on the drawing, yeah, I'm going to heavy in this up to just about there at the moment. And the bit I'm not going to heavy in, but I'm just going to highlight it a little bit. Because obviously that'll go to there. Once again, not going to heavy it in to there. This guy will probably connect down to about here, ever so lightly. And you can kind of see the structure there that we're building. Okay, you can see the structure there. If this was to continue on, make the back face and the side face and so on. The only reason I haven't heavied those in is because I know there's a curve going here and there's a curve going here. So how are we going to complete that curved section? I'm just going to zoom in there now so it kind of comes in on the screen a little bit more fully. Just about there. Yeah, I'm happy with that. So how are we going to complete that curved section? So we're going to use ordinates to split up this section over here. I'll actually do it on this side. It's probably a little bit easier. So if I actually look at the section here, you can see here it's kind of broken up into almost 15 millimeters from 0 down to 15 there. So I'm actually, a sensible measurement to take would be cuts of 5 millimeters. So I'm going to go 5 and 10. If I've marked down 5 and 10 here, I also have to mark it over here. And I already have the height line over here done. So 15. So it's going to go, what I'll actually use is my compass. A bit more accurate. So take this first height. That height there. I'm going to mark it up here. The next height. I'm going to mark it up. And likewise, the final height. I will also mark this up vertically. Okay. Now that I've that done, I'm going to put in those cuts see here, yeah, you can see they work out perfect. So this one is obviously just at the very topmost point, that's fine. There's the second. There's the third. Okay, I have to do the exact same over here, parallel to this line here. Because I obviously have a curve at the front and the back. There's the ones at the front. Okay, so if I was to use lettering, and we just focused on the front section, okay, and if I was to use lettering, I'm going to call this point A, B, C. I've obviously got a topmost point, which I need to find exactly. So it's going to be parallel to here. So to find that point exactly, it's going to be directly above the center. You can see there. So there's my D, E, F, and G. So the same principle. If I wanted to find A to G, I need to find them over here. So A is at this height. So I've got A here, then it will go up to B, then to C, to D, back down to E, which is at the same height as C, then to F, and then to G. So all of those, if I want to find them, just follow the method, okay? So it's simply a case of projecting across. Now I've already got two of them. I have A and G. Now I want to find B and F. Just make sure you're projecting down perfectly. So somewhere along there is going to be B and F, E and C, then finally the letter D at the top. And likewise, as we did there, I'm going to do the exact same on this side. So A is down. I'm going to have to bring them down individually. So this one here is B. Then the next height up is going to be C. Then finally D. And we're going to continue on. Put it back down and actually go across the other way. Just move my set square. Running out of space. Then I've got E. And I've got F. And obviously G is already got. So let's locate those. So there was A, B, C, make sure you get D, and then put it out here, E. F was on the outside, F is opposite B, so there's B. I made a mistake there, sorry for the E. Just should have extended it down a little bit further. Should have been on to the next one. So E was actually here, apologies. Then we had F, then we had G. So what I would simply do then is, now that I have the points, as best I can, ever so lightly first of all, sketching those in. Trying to follow the natural curve. So that was E, not this one. So there's E. F down to G. Now that I have the path, as best I can, I'll start heaving all those in. Try to make it flow smoothly as possible. E to F, and obviously F to G. And you can see here now, I can actually determine how far this was heavied in as. So that's the inside portion. Now that we've got the curve at the front, we simply just have to get the curve at the back. So it's the same principles that's going to follow. So all these lines here are going to project down, parallel in this case to the Z axis. And all these ones have been brought down already. So it's simply a case of locating those. Now the first one is here, obviously over here. Then the next one will be this height. Then the third one, just making sure I have the right one here. It's going to be on the C, so it's here. Then D will be up here. Then finding E This will be the lowest one. It should be right here. Make sure I have the right one yet. F is on the outside. And there we go. So that curve as well, once again, just making sure I have the right ones yet. You can see the curve there at the back. Just down to here. And once again, heavy it in as best you can. And now that we have that, the edges here will connect in a straight line, like that. Okay, so there you have it, guys. I'll just zoom out there ever so slightly. And as you can see, we have now completed the diametric of the object. So if I was just to sketch that in our sheet, sorry, I'll click off the C there. That was kind of, if I was to put that in, what we've kind of done there now is something like that. As best I can, just sketch that in. Something like that. That's the object completed there. Okay, we're obviously we heavied in this portion of that edge running inside there as well. Okay, so that's the part C done of the question, guys. Now we're going to move on to the final part of this question. And it says here, in the pictorial projection, identify the traces of the simply inclined plane that contains the sloped exit. Okay, so what we're moving on here now is something called like the oblique plane. Okay, so they're introducing something else in here. It's a final part of the question. It's going to be worth a couple of marks. Okay, and often it can be a part that will catch out students, but it's not that hard. So what they're asking us to do is identify the vertical traces, identify the traces. And anytime you see traces, what they're associating is the VTH, the vertical trace, and the horizontal trace. Now, they're essentially saying we've obviously got a curved surface here that has been cut, okay, and it's been cut by a plane, a simply inclined plane that's going like this, simply like that. That came along and it sliced it at that angle. Otherwise, it would have been perfectly upright, but it's after cutting off that section there at the front of it. Okay, we need to identify that. Now, it makes sense because we already have one here. We've got the direction of this, we've got the direction that it's been cut at. So one of those planes where it hits the x-axis right here, that there, if I was to extend that on, the line BC is actually our vertical trace. So that there is our VT. Okay, that's our vertical trace. And then our horizontal trace is simply where that simply inclined plane is coming along and it's cutting through the horizontal plane. We know the horizontal plane is down here. So that has to be running along there. That is our horizontal trace. And essentially our plane is like this. If I had a little bit of a color, I'd be putting my plane in there like that. And that's the plane that I'd be shading in. Okay, so just for identifying those two lines, even though we have them already drawn, we have to identify them to get the marks. Okay, so I'll tick that off there. To identify those, simply I'm going to use, I'll actually grab a color if I have one here. I have one in my pencil case. Put it in with a marker actually. Yeah, put it in with a marker. Just to identify it. So, using this blue marker here, we've already got my plane. Remember, this section here between the y and the x-axis is my vertical plane. So where my simply inclined plane cuts through that, where it cuts through, it will leave a trace. That trace is known as the vertical trace because it's on the vertical plane. Okay, there's the trace there. It's along the BC. Just going to heavy that in. That there is my VT. And then where the vertical trace, or sorry, where the simply inclined plane cuts through the horizontal plane, which is down here, which is the ground, the horizontal plane. Where that vertical, or sorry, the inclined plane, simply inclined plane cuts through the ground, will leave a horizontal trace. And that there is my HT. And as I said there previously, what would often we would do in class is we'd put in something like that there, and we would color it in, and that is showing obviously where the cut surface of the structure is. Okay, but simply for just identifying two lines, very easy marks to pick up if you understand the principles of the oblique plane. Okay, so that question there, guys, is the 2011 higher level section B question. Okay, nice little axonometric axes method question where we did the projection in dimetric. Okay, so that's the question done there, guys. I hope you found that helpful.